Greetings, water and health class, and in this particular class we're going to focus on a particular topic that relates to not just Flint, Michigan, but also water all over America. And the video we're going to get into is going to pertain to corrosive water, and I'm going to mention the risk for private drinking water systems, but before I go into much detail on that, we're going to discuss a couple of America's heroes, and we're going to discuss Flint, Michigan. So this particular professor here, and she's also a pediatrician, medical doctor from Michigan State University. She had been working at the University of Michigan, I believe, or may have been Michigan State's hospital in Flint, Michigan. This is Dr. Mona Atisha. Dr. Atisha is the medical doctor who noticed the elevated blood lead levels in the children, and she fought a battle against the Michigan Department of Health and the governor of Michigan and a lot of the other folks who were denying that elevated blood lead levels existed in these kids. And she particularly looked at kids from one particular area, but when you looked at the whole system, there were no examples of an average blood lead level for the kids across the whole system being high. But when you looked at one particular area like she did, she was saying, no, it's really high in those kids. And she got a lot of awards, and I've been fortunate to get to interact with her in a variety of environments. And she's not a water expert by trade, but she was a person who was a medical doctor who stepped up and was a true hero for a lot of those people in Flint. Over here on the right, this is Dr. Mark Edwards. Dr. Edwards is an environmental engineering professor, civil engineering professor at Virginia Tech, there in southwestern Virginia in Blacksburg. And Dr. Edwards is the doctor. He's not a medical doctor, but he's an environmental engineer. And he is the person who first blew the whistle on the elevated lead levels in the kids in Washington, D.C. from the corrosive water associated with the switch to chloramine. And then when people in Flint had all the orange water, and about the same time Dr. Atisha was finding the elevated blood lead levels in the kids, Dr. Edwards was asked to intervene, and he got the complaints from the community. He gets a lot of complaints from people all over America and the world, but their particular situation was so apparent, and the evidence was just so overwhelming, he thought he had to do something. And he did. And the rest is history. So we'll get into a video on kind of what makes water corrosive, and then what's the potential in our groundwater users in southeastern Kentucky. So some of the data that I got came from Kentucky Geologic Survey. And obviously, as I just mentioned, and you saw the videos, if you watched some of the videos a couple weeks ago, recent events, notably Flint, but there have been other towns where we've had concerns about drinking water and lead exposure. Martin County is one where that was a concern that people had too. Thankfully, there's not a lot of lead in the Martin County system. Pipe and weld corrosion, pipes that are made of lead and then corrosion of welds where the pipes are joined, is a potential mechanism for lead to be transported in the system. Now, lead in the water is not something that's necessarily new to Flint, Michigan. Lead in the water is something that's existed and been known about for a while. Pipe and weld corrosion have been linked to elevated lead levels for a long time. Water engineers and water resources professionals have known about this since at least 1936. And they have recommended modifying water chemistry or adding anti-corrosion agents like we just talked about in the previous video, like zinc orthophosphate, since 1936. And I'm going to give you a quote from this paper from the Langlayer, is the author. So he said in there, in this paper, a rust coating not establishing calcium carbonate is too porous and not sufficiently dense and continuous to offer protection. So we don't want rust coating on the inside of our water pipes. And to the contrary, it may even accelerate corrosion. So once rust starts forming, it creates more pits and makes it easier for biofilm formers and all kinds of other downstream effects where the pipes can actually corrode quicker. And then even this stuff sloughs off and gets into people's pipes in big chunks, one at a time. And those chunks may have high levels of lead in them as they've accumulated in bits and pieces of the pipe over decades. Many of the pipes we're talking about are decades and years of age old. Dr. Edwards says it is argued that water distribution systems are the key public health battlefield of the 21st century, and private plumbing also deserves special attention here, since the health and economic impacts are probably of greater or equal magnitude compared to public systems, and there's been no advocate working on behalf of the consumers to solve these problems. So that's Dr. Edwards speaking about private plumbing, even though he had to intervene. That's in 2004. This is a decade before he had to intervene in Flint, Michigan. So this is a picture from the gentleman at the US EPA showing you a Flint, Michigan pipe right there versus a nearby Detroit water system pipe. This is what the good protection of an anti-corrosive compound like zinc orthophosphate does to a pipe. This is clear evidence of pitting and corrosion and rust of a pipe. Flint did not have corrosion control. Flint, Michigan was ordered by the governor's emergency manager against the will of the Flint Town Council to switch to Flint Public Water, to make Flint Public Water operational again, to fire up an old drinking water plant and draw water from the Flint River and send that to their consumers after treatment, when they had been using Detroit Public Water for decades. Detroit Public Water wanted to explore options to get consumers off their system. There was a potential buyer for the public system, and they were looking at selling it, and they didn't want the future buyer to have to worry about dealing with the fact that Flint, which used to have a GM plant, closed down, a lot of laid off workers not paying their bills. Detroit, or their future owner of their public water system, which would then be privately held, did not want the burden of cutting the Flint people off the water system. So Flint was told by the emergency manager of the state of Michigan, assigned to Flint, you must use this. Town council voted against it. It was still rammed onto them. And they continued to use it. General Motors refused to take water from Flint, Michigan. General Motors was getting water from Flint, and then the cars at their Flint plant were having rust problems, and the steel was having rust associated with that water. So what did they do? They switched back to Detroit Water, and they're General Motors. They had the power to do that. So the Flint River itself was more corrosive, and the Detroit public water system was getting their water from one of the Great Lakes. The Great Lakes aren't as corrosive as the Flint River. And there's a reason why things are corrosive or not corrosive, and we'll cover that here in a minute. So was corrosion a real issue? Flint, Michigan, their residents said their pipes were corroding. The state said, no, you're full of it. Mark Edwards had the kids do a class where they put nails in the water from Detroit water, nails from bottled water, and nails from Flint, Michigan. And here's what it looked like 30 days after a nail, same nail, from same box, sat in Flint water versus the water from Detroit. So what do you think? And this was consistent for all the kids. So even the little kids in the elementary schools could see this. So we can prevent this stuff. We can prevent it. So we can add chemical anti-corrosion agents. Chemical corrosion speeds up microbial corrosion. Microbes will get in there and pit, and it's a positive feedback loop. It gets worse and worse. As chlorine is used up, bindings increase the metals, microbes can get more easily established and attached. There's usually an increase in heterotrophic plate count bacteria, the bacteria that live in the pipes. And then the microbes, they can create this positive feedback loop. It's an awful situation. So could they have prevented these problems? I'm going to put this slide up there and I'll give you the answer in the next video. So how much money would we have had to spend to prevent Flint's pipe corrosion problems? $14, $140, $1,400? Because they've got millions of dollars, tens of millions of dollars. I don't think it's in the billions, but maybe hundreds of millions. It's outrageous how much. I'll look and see how much that expense is to fix the system right now, but how much could they have spent per day to prevent all of it? So I'm going to stop the video there and we'll continue here in a few minutes.